Hello everyone, welcome to Tech Hand. The human-robot production process in Korean factories has been rapidly evolving and has had a significant impact on manufacturing efficiency and productivity. The integration of robots in the production process has led to several benefits, such as increased productivity, reduced cost, improved quality control, and enhanced safety measures. In the traditional production process, human workers are responsible for performing repetitive tasks, such as assembly, welding, and material handling, which were time-consuming and physically demanding. However, with the introduction of robots, these tasks can now be performed with higher precision, accuracy, and speed, thereby improving the overall efficiency of the manufacturing process. Robots have also enabled Korean factories to operate 24/7 without the need for human workers, which has led to increased production output and reduced manufacturing costs. Additionally, the use of robots has allowed factories to implement just-in-time production strategies, where products are manufactured only when required, reducing inventory and associated costs. The integration of robots in the manufacturing process has also led to improved quality control. Robots are capable of performing repetitive tasks with consistent accuracy, reducing the likelihood of errors and defects. This has led to improved product quality and higher customer satisfaction. Finally, robots have contributed to enhanced safety measures in Korean factories. By automating hazardous tasks and removing human workers from potentially dangerous situations, the risk of workplace accidents and injuries has been significantly reduced. The human-robot production process in Korean factories has led to increased manufacturing efficiency and productivity, improved quality control, and enhanced safety measures. As technology continues to evolve, it is expected that the role of robots in the manufacturing process will continue to grow, leading to even greater benefits for Korean factories and the global manufacturing industry as a whole. The production process of human-like robots using a 3D printer in a Korean factory could involve the following steps. Designing the robot. A team of engineers and designers will work on creating a digital design of the robot using 3D modeling software. The design will include all the necessary components, such as sensors, motors, and batteries, that make the robot function. 3D printing. The 3D printer will take the digital design and use it to create the robot's parts, layer by layer. The printer will use materials such as plastic or metal to create the parts. Assembly. Once all the parts are printed, they will be assembled together to create the final robot. This will involve attaching the motors, sensors, and other components to their respective places. Programming. The robot will need to be programmed to perform specific tasks. A team of programmers will work on writing the software that will control the robot's movements and actions. Testing. The robot will then be tested to ensure that it is functioning properly. This will involve testing the robot's movements, sensors, and other functions. Quality control. After testing, the robot will go through a quality control process to ensure that it meets the required standards. Packaging and shipping. Once the robot has been approved, it will be packaged and shipped to the customer. This will involve carefully packing the robot to prevent any damage during transit. Maintenance and support. After the robot is delivered to the customer, the manufacturer may provide ongoing maintenance and support to ensure that the robot continues to function properly. The production process of human-like robots using a 3D printer in a Korean factory involves a combination of design, engineering, programming, testing, and quality control. Korean factories that produce human-like robots implement various quality control measures to ensure that the robots meet the required standards. Before the robot is released to the market, it undergoes rigorous testing and evaluation to ensure that it functions correctly. The testing includes checking the robot's movements, sensors, software, and other functions. After the robot has been tested, it may be certified by a recognized organization or regulatory body. This certification ensures that the robot meets safety and quality standards and is fit for use. Korean factories also implement continuous improvement processes to improve the quality of their robots. This involves analyzing feedback from customers and making necessary changes to the design, engineering, and production processes. Korean factories also ensure that the quality of the raw materials and components used in the production of the robots is maintained. They implement strict supply chain management processes to ensure that the materials and components meet the required quality standards. Korean factories also provide regular maintenance and support services to their customers to ensure that the robots continue to function correctly. This includes providing software updates and replacement parts as needed. The production of human-like robots in Korean factories is expected to continue to evolve and incorporate new technologies to improve the functionality, appearance, and performance of these robots. Korean factories are exploring the integration of AI to enhance the capabilities of human-like robots. By incorporating machine learning and deep learning algorithms, these robots can become more intelligent, adaptive, and responsive to their environment. The use of advanced materials, such as graphene, carbon fiber, and nanomaterials, is expected to increase in the production of human-like robots. These materials offer improved strength, durability, and flexibility, allowing the robots to perform more complex tasks. Haptic technology, which stimulates the sense of touch, is being developed for use in human-like robots. This technology allows the robots to interact more naturally with humans and their environment, improving their ability to perform tasks. Korean factories are exploring the development of human-robot collaboration systems that enable robots to work alongside humans in manufacturing, healthcare, and other industries. These systems allow humans and robots to share tasks and work together to achieve common goals. Korean factories are also exploring the use of personalization in the production of human-like robots. By using 3D scanning and printing technologies, robots can be customized to meet the specific needs and preferences of individual customers. The future directions and emerging technologies in the production of human-like robots in Korean factories are focused on improving the functionality, appearance, and performance of these robots. By incorporating new technologies, Korean factories can continue to produce high-quality human-like robots that meet the needs of customers around the world. Are you enjoying our video? Before we continue with the video, please make sure to click the subscribe button and hit the bell icon. Also, turn on the notifications so you don't miss out on more amazing videos from us. Let's continue to see the human-robot mass production process with new 3D printer. Designing human-like robots involves a range of considerations relating to anatomy, movement, and sensory systems. Human-like robots need to be designed with a similar anatomical structure to humans to enable them to perform tasks similar to humans. This includes considerations such as the number of limbs, range of motion, and joint placement. For example, robots designed to perform tasks that require fine motor skills, such as surgery, need to have hands and fingers that can mimic the dexterity of human hands. The movement of human-like robots is also an important consideration. The robots need to be able to move in a way that is similar to humans, which requires consideration of factors such as balance, stability, and energy efficiency. For example, robots designed for tasks that require fast movements, such as sports training, need to be able to move quickly and maintain their balance while doing so. Human-like robots also need to have sensory systems that enable them to interact with their environment in a similar way to humans. This includes considerations such as vision, hearing, and touch. For example, robots designed for use in manufacturing need to have sensors that enable them to detect and respond to changes in their environment, such as the presence of obstacles or changes in light levels. Safety is another important consideration in the design of human-like robots. The robots need to be designed with features that prevent harm to humans, such as sensors that detect the presence of humans and stop the robot from moving if a human is in the way. Finally, the appearance of human-like robots is also a key consideration. The robots need to be designed in a way that is aesthetically pleasing and can help to create a sense of trust and comfort in humans. This includes considerations such as the robot's facial features, expressions, and body shape. The design considerations for creating human-like robots are complex and require consideration of a wide range of factors related to anatomy, movement, sensory systems, safety, and aesthetics. By carefully considering these factors, designers can create robots that are better able to perform tasks and interact with humans in a natural and intuitive way. The production of human-like robots could have significant social and economic impacts, including job displacement and changes in the nature of work. As robots become more capable of performing tasks traditionally done by humans, there is a risk that they could replace human workers, leading to unemployment and economic disruption. It is important to consider the potential social and economic impacts of robot production and work to mitigate negative effects. Another important ethical consideration in the production of human-like robots robots is the question of autonomy. As robots become more capable of making decisions and taking actions independently, there is a risk that they could act in ways that are harmful to humans. It is important to consider the ethical implications of robot autonomy and to ensure that robots are programmed with a strong ethical framework to guide their decision-making. Safety is another important ethical consideration in the production of human-like robots. It is important to ensure that robots are designed with safety in mind and that they are not programmed to perform tasks that could put humans at risk. Additionally, it is important to ensure that robots are designed with fail-safes and backup systems to prevent accidents and minimize the risk of harm. Thanks for watching. Don't forget to subscribe. Let us know in the comments that you're subscribed and what you think of this video. We'll reply to you personally. You can also give a thumbs up. Thanks for that.